Welcome back, everybody. Got a little bit of time, so I thought I would just continue here and go to the next function, which is partition. Excuse me. So reading the type signature, we had this type constraint where f is a filterable. So if you think about what's filterable, numbers are filterable because they have an order. Um, Letters or characters are filterable because there's an order in the alphabet. Um, I don't think you could filter true or false. If you did, then it would be like one is true is one, zero is false. So, you could filter it ascending, descending like that, but I don't think you would. But I think essentially we're going to be talking about strings and numbers. And then it takes a function. It takes anything and returns a Boolean. So this is a predicate function. And then it takes an A, which needs to be a functor, or sorry, needs to be a filterable, and returns a pair of A's. And of course, A's are still filterable. Here's some useful information. So the first thing it takes is a predicate to determine which side the element belongs to. So that doesn't really make any sense without reading the definition, but it will. And then a filterable, which is the list or other filterables to a partition. Maybe they'll give us an example of other filterables. And here's the thing, it returns an array containing first the subset of elements that satisfy the predicate, and second the subset of elements that do not satisfy. So what this is basically going to do, let's just use a list as an example of the A. Um, we're going to pass the A through a predicate, and if it's true, it's going to be on one side of the result, and if it's false, it's going to be the other one. And I find this to be a very useful function in real world application. Coming up with an example is a different story, but that's what the documentation is for. They've already given us examples. So let's read the definition first. It takes a predicate and a list or other filterable object and returns the pair of filterable objects of the same type of elements which do and do not satisfy. Um, oh, okay, I see. Let me start over. It takes a predicate and a list or other filterable object and returns the pair of filterable objects of the same type of elements which do and do not satisfy the predicate respectively. Respectively, not respectively. Um, Filterable objects include plain objects or any object that has a filter method such as the array. So this is just more about what is a filterable. And it says see also filter and reject, which was already looked at. Filter was Chris's last function in the original series he did. And reject is just the opposite of filter. Um, so let's look at this example. Let's put it like this to make it easier to read. So partition takes a Boolean, or it takes a predicate. And the predicate that we're using is includes. Uh, does the do these items include S? And so if we look, this obviously includes an S, and this one does not, and this one does not, but this one does. So what we're going to get back is we're going to get back an array with two subarrays in it. The first one is going to be the items that return true when we apply this function to it. And the second one's going to be an array of items that does not pass this predicate. So basically able to split a list based on the things that are true or not. This is similar to filterable or filter, filter is just going to go through and apply it and just give us back only the things that do um, satisfy the predicate, but it's going to ignore the elements that do not. And so this one gives us a list of both the ones that do and don't, kind of like filter and reject combined. Uh, so let's log that, see what the result looks like. And so here we go. We've got the outer array and then the inner array, two arrays. These are the values that satisfy the predicate, and these are the ones that don't. Um, without this, the obvious way, and maybe the only way, probably not though, let's say X's, that's that array. And we could do like, I'm just going to do these one at a time. I'm going to say yes is X's, or use random functions. It would be r dot filter, um, r dot includes the letter S, applied to that, and then we log ES, and so we get the same thing we got in the first one. And then we could do the same thing, but instead of going filter, we call reject, spelled correctly, and that'll be the no. Probably knows, probably should use plural for the name, but it doesn't matter. Yeah, and then we get the other one. And then we could do like r dot pair, yes and no. And then that gives us the exact same thing that partition gave us. Yeah, so I find that pretty useful. And the same thing. And here where I say log equals console log, I often do const keep equals r dot filter, because I have a hard time remembering if like filter keeps the things or rejects the things. So since we have a reject, I feel like we should have a keep. And I don't really do that with Ramda. I do that with other libraries that I made. So yeah, this one doesn't like r dot keep. It's not a function. Oh, yeah, it's not r dot keep. It's the one I made. Yeah, and that works the same way. So that might be helpful. If you're going to use reject a lot, maybe make an alias of the r dot filter called keep. Yeah. Um, oh, click too hard. Partition. So this is using the juxt function. And I remember that it's kind of like a big deal, but I can't remember what it does just now. Let's go back and look at it. That supplies a list of functions to a list of values. Math.min and math.max applied to this list of values. Okay. So what they're doing is they're doing exactly what I just did. They're but just in one go. Let's duplicate that. Um log it. I'll just actually we'll log it like that. So we go r.juxt and it applies a list of functions. So we could do um a list of functions. So we could do r.filter, r.includes the letter S. That's one function. And then the second one would be r dot reject, r dot includes letter S. Of course, I could partially apply that same function. We're calling it twice, but this is just for playing around. All right, so that's that, and then a list of values, which is going to be our x's. Let's see if that gives us the same result. Does not. Applies a list functions to a list of values. Oh, do we have to passing in an array? But in the example, it's not an array. It does say a list of values, but so I think we need to spread it, but we don't. It may or may not be the right one. R dot filter. I'm passing this. Okay, wait. It takes a, a list of functions, and then it takes them. Here it looks like it's taking. Oh, okay. Yeah. I think it just takes the list of functions and it returns a function. Yeah, it returns a function. So I need to apply it like this, I think. Yeah, and then we get the exact same thing that we got. So partition, I couldn't remember the name of it, of the function we were looking at. Partition is just a convenient uh, version of juxt. Yeah, and so I think that's why it's good to look at the implementation because sometimes it looks scary, but other times you can understand some things. So I think I'm going to do one more. Have we looked at path and path equals? Yeah, we did, didn't we? Retrieves the value at a given path, and then so you just provide the path. We did look at path. Probably when we looked at nth, and we looked at prop because that one's used so much in the examples. And I'm sure Chris looked at assoc path and disassociate path in his original series. And then we looked at path EQ. Yes, it's famous. We provide a value 90210, and then the path to where that value would be, which would be first an object with an address nested inside that property called zip code, and it has that value. So if the value of the path equals 90210, here's the path, then we get the value back. Interesting. It says we get an array of user one. Oh, I see. They made these objects and then they just put them together here. So yeah, it tells us which one that works with. We've looked at equals. Yeah, we've looked at all these path ones. Now, if I'm wrong, leave a comment and I'll go back and we'll look at these closer. But I don't want to redo something that I've already done. Path or I feel like I've done that one as well. After I record this video, I'll go through and look and see. Um Path or NA, yeah. So this is basically like the same thing as path, but if it doesn't exist, you get a fallback, which would be NA. And this one is paths, so paths with an S, same thing as path, but you give it more than one path. Hmm, what if I haven't looked at these? Let's just go through them. It's not going to hurt to duplicate these things. Sorry about that. That's why, I don't really plan these videos, just kind of doing it off the top of the dome. All right. So path takes a list of indexes and an object, with any type A, and it returns either A or undefined. Index can be either a string or a non-negative integer, right? Or it can be a string and enter a symbol. So essentially, the path, the index is going to be the key in the object that you pass in. It retrieves the value of a given path or at a given path. The nodes of the path can be arbitrary strings or non-negative integers. For anything else, the value is unspecified. Integer paths are meant to index arrays, and strings are meant for objects. Okay. Integer paths are meant to index arrays, strings are meant for objects. Let's use their example. And sorry, let me clean up these comments to make it easier to read. Okay, so these are just individual function calls. So let's just do them one at a time. So in this one, we're passing an array of A and B, and those are our path indexes. And then we give it a object with one property A, which the value of that property is another object with one property B that points to 2. And then we run it, and we get absolutely nothing back because I didn't save. Because I didn't save. And we get 2 back. So at the path A and then B. So start at A, and then inside A, you go to B. And is there a key here? Yes, there is to give us back the number 2, but otherwise we would get back undefined. So if this is a C or an X, we get back undefined. All right, let's look at the next one. I'm feeling deja vu, guys. I feel like I've done this, but whatever. So here we're providing the same indexes. We're looking for an object with A, and nested inside that an object with B, and then we're passing it a C with a B in it. There is no A, so it should get me back undefined, and it does. That's what they say. I like when they give you a lot of examples, so you can do that. So here we're looking for A and then B and then 0. So we're going to have an object with a property called A, and nested inside of an object with a property called B, and nested inside that an array. And if that array has one item in it, which will be index 0, then we'll get that back. And here we have an A and nested as a B, and inside that the value of B is an array. We should get 1, and we do. So that's what it means by the nodes of the path can be arbitrary strings or not negative integers. For anything else, the value is unspecified. Here we go. Integer paths are meant to index arrays. Strings are meant for objects. So if you have an integer, it's zero. So that's why it says it has to be non-negative. Wouldn't make sense to have a -1 or look for a value in an array at the -1 index. Um, I know sometimes you do -1 and you count backwards and like slice or at method or inth or whatever, but that's not what I mean. That makes sense there. What does this one do? So here we got an object with an A, an object with a B, and then a -2. Okay. So in this case, we're going to count backwards, like I was just saying. We do. We A and B. So here's the A, and inside that is an object called B, and there's an array. We go -2. This would be -1. This would be not -2. So we get 2. Cool. Or we get undefined. Yeah, this is nice because we could, this would reduce having to write if statements or use like optional chaining and stuff like that. This might have been out before optional chaining was introduced to uh, JavaScript. Yeah, so it is pretty useful. There's only two more. This one we're looking for an array, and the third item. No, no. Hmm, it's a little interesting. We get two. Oh, this isn't an array. This is like if you had something like obj and then you use this for like the name property in it, or like if you're trying to get something by a variable name, something like that. Because I think this two refers to this two is the key in this object. And JavaScript behind the scenes is converting this two into a string. So we got some conversion coercion going on. So like if I change this to three, we should get undefined. We do because this is not a three. But if we change this to three, then we'll get back two. We get back two. I don't think you could use this much, but I mean, at some point you're gonna have something weird, and this is the only way to do it. And then this last one, -2. Yeah, this should give us what's this non-negative indexes, and this is a string for an object. So that's why we're getting get back undefined when we run it. We do. But if we change this to a two and change this to a two, then we should get back A. We get A. Yeah, I don't think we looked at this. So I'm glad I'm going through it. So I'm gonna do one more. We'll do this path equals. This one takes an A, so like anything, and then it takes an array of indexes. The index can be a string, an int, or a symbol. And then it takes an object and it gives us back a Boolean. So this is a predicate function. A is a value to compare the nested property with. Path is the path of the nested property to use. Object is our data, the object to check the nested property in. And returns a Boolean. Returns true if the value equals the nested object property, false otherwise. Let's look at the example and then read the description, or you can always pause it and read the description. We've got some data here. These are one, two, and three. They're objects. These two have the same type of data. This one does not. This one has name and Bob. These are nested objects. This is just one flat object. And then we stick them all together in an array. And then we're going to use our path equals. So what we're saying is given our value, A, 90210, the number, and a list of indexes, address and zip code, this is going to tell us if the given this path, is this the value that we're going to get? That's the Boolean side of it. It's a little odd because they're using RDEP filter. I almost want to say, let's not do that. Let's just log is famous and see what that gives us, true or false. It gives us a function, but it doesn't return a function. That's a little odd. I mean, it does return a function. We see it. A function takes one argument. But here, it does not tell us it's returning a function. It tells us it's returning a Boolean. And obviously, it is going to return a Boolean because is famous, if we bring this back, is famous is a Boolean. Filter function takes a Boolean or it takes a predicate. Shouldn't say it's a Boolean, it's a predicate. It takes a predicate as a function. So this is like a predicate. And it tells us here it returns a Boolean. So let's run that, save it, and then run it. Oh, wait, no, we want to run this. So here we're just getting the addresses. So I feel like, oh, okay, going back, undo, okay. Is famous, yeah, like who's famous? We need to pass it to the users. And we get false. Oh, and that's why they're using filter because, okay, if I did is famous user one, we're going to get true. And we do. Because if we follow the path, first we go look in the address, and then we look for another object inside the address called zip code, and we get that value, which is 90210. And is that equal to 90210, the first value we pass in? Yes, it is. We get true. If we did two, we get false because if we follow this path, we get 55555, and that is not equal to this value that we're checking with. And then if we do three, we should get false because there's no address, so you can't even get to the zip code to check the value against this. But it doesn't crash, and it just gives us undefined. And then so if we log this, we're just going to check all of them at once and get back a list of the things that pass, which should be an array of one thing. And there it is, the address, zip code 90210. Yeah. Okay, that's handy. I am going to keep going to do path or. I'm going to do all three of these path or paths and path satisfies. You have the power of the pause button if you don't want to go this far right now. The path or it's the same signature almost. This takes the value that we want to check that exists in this path that we're going to give it. And here's a list of indexes that's going to tell it how to get, what the path is. And then the object that may or may not contain the path. And then we're going to get an A back though, instead of a Boolean. So it's not a predicate. And if we look at the signatures, so this is the default value, like the 90210 we just looked at. P is the path to use, and object obj is the object to retrieve the nested property from, and it returns anything, is what it says. I think that's what that star means. It's the data at path of the supplied object or the default value. And so that's the deal. That's why it says it can return anything right here. Because so this is just basically it's going to return the thing or a default value. So it's basically got a default built in. Let's use their thing. This could be handy for like if you had a list of users or something, and if they didn't have a user role, then you would default to NA or default to guest or something. Let's do what we did last time. Let's just move this into the log and run it. We get two. So the fallback is going to be not applicable. That's hard to say. NA. Here's the path A and B. This one works because we look for the path A, and inside that, the path B, and the value of that is 2, and we get 2. But if the value was, if the path did not exist, we would get the fallback, which is in A. Very much like a replacement for optional chaining or null coalescence, which is like this guy, the double question marks. And that was introduced in like 2020, 2021, or something. And then let's look at the other example. So our fallback is in A, our path is object with A, and then the value of that object A would have an object with a property called B. And this is what I just showed. Basically, there is no A, so we're going to get NA back. It's our fallback, and we get NA. Yeah. So just a more specific version of path. I skipped one. No, okay. And so paths, look at path again real quick. It's interesting because this does take two arguments for the path, or it can take two. It could take more than two, but it could take one, two, or three. I thought paths would require more than one. Look at the type signature. A list of indexes, an object, and it returns either something or undefined. Ah, this does the same thing, except it returns a list of results instead of just one result. That's where the S comes from in paths. So this list of indexes is a paths array, the array of paths to be fetched. And then this is our object, the object to retrieve the nested properties from. And then it returns a list, not a thing, but a list consisting of values that pass specified by the pass array or undefined. They don't mention that here, but it may not exist. And if it doesn't, you'll get undefined. So let's look at their example. So list of indexes. So what we've got here is an object. So it's looking for a path with an object with an A, nested inside that, an object with the B. But then we're also providing it another one. So an object with the P that it holds an array, and that array would have an item, one item in it at least, the zeroth item. And then that item would be an object which would have a key called Q. Yeah, it's almost like a test or something. Um, and then so we provide it. So here's one with an A and a B, and that's two. So that works. And then this one is a P, and that's here. And the value of P is an array, and it has an item in it. So that's the zero. That item is an object with a Q. And so we should get back an array of two and three, is what I think. Well, I just cheated and looked at the comments over here. That is correct. If I save it, we get two and three. Yeah, so this is basically like just like otherwise you could do the same thing with just path, but first you'd have to do this one, A and B, and then you'd have to do it again for this one, P0Q, and then you would have to use like a pair function to group those into a list. So this just does it automatically. Yeah. So very similar. Um, Pretty cool. And again, this is version 27. Path was version 2. So somebody probably got tired of having to manually make this function out of path and other functions like pair. And then the last path one, let's look at pathSatisfies. And so we've got it's a Boolean or a predicate function because it returns a Boolean. So the first thing we do is we pass it a Boolean. Oh, sorry, we pass it a predicate function, which takes an A and returns true or false. And then we pass it a list of indexes, which we know at this point are going to be paths. And then the object, which is our data. And then it's going to return true or false. Probably looks for it and then determines if it matches the predicate. Yeah. So like it would take the A, and that A would be the input for the predicate function, and it would ask a question, give you back true or false, which would be that. Yeah, so the first argument is predicate. The second one is the property path specified by indexes, and then the object, our data, and it returns true or false. So it returns true if the specified object property at the given path satisfies the given predicate, false otherwise. Yeah, that makes sense. Parentheses are the enemy for me. So this takes the predicate and the list of indexes. What I want to do is I want to take this argument out and name it obj. I just feel like it's cleaner. Do it like that. So let's run it and we get true. So the predicate function is going to take a value like x. Oh no, first, okay, so first we drill down through the object. We look for the x, and there's the x. And it has a nested object in it called y, and there's here, that's what we're looking for, y. We're looking for the value of y, which is 2. So 2 becomes the y in our predicate. So if 2 is greater than 0, we're going to get back true. And we got back true. And so if y was -2, we would get back false. But if y was 2, but we changed y to z, we get undefined or false. We get false. Yeah. We get false because the thing is it's a predicate. Like if it's there and it's true, then it's true. If it's not even there, then it's false. Not because it didn't pass the predicate, but because it just wasn't in our path list. Yeah, there we go. So yeah, there's all the path ones. And it looks like the next one we're going to do a bunch of pick ones. We know what pipe is, but pipe width looks pretty cool. Yeah, I'm just looking. We looked at project before. We haven't looked at pro map. We've looked at prop. We looked at prop equals. I think that's what I was getting confused with path equals. Anyway, thank you for spending your time with me. Tell a friend, and I'll see you in the next video.